Welcome back, fellow explorers, to Project Opono. In part 1 of this episode, we explored the diversity of the land dwellers on Ep7.2. In this part, we will travel over to Mazi to continue to expand the terrestrial ecosystems. Soon after the virophytes evolve on Mazi, the Xenodendro will make landfall. Similarly to the Parvicormo, the Xenodendro evolved around inland rivers and lakes. This may mean that the Xenodendro may convergently evolve in the same way the Parvicormo did, evolving niche partitioning with the Tawamosu, while evolving into the dominant rainforest flora. These new Xenodendro may grow much taller than the Tawamosu or the Gavarazafita, due to the Xenodendro being larger than the Parvicormo at the time they evolved. These plants may have the same general body plan as their ancestors, with only 3 major differences. The roots of the Xenodendro may evolve into buttress roots to support the large body of the plant, and the leaves of the plant may evolve to segment into 4 for greater surface area. However, the ancestral trait of root flowers may not be as effective as it used to be for reproduction in these new trees due to their large height. As a result, these Xenodendro may evolve to have their flowers grow along the main body like branches, to have the best chance at being fertilized and forming fruit. This may make these trees very similar to the Jabuticaba tree of earth, having flowers and fruits along the main trunk, so that animals looking for a quick meal can get one. We will call these strange trees the Parvicormo. They grow up to 35 meters tall and will outcompete the dominant rainforest, Tawamosu, and become the new dominant form of rainforest vegetation. After some time, the tetradecapods and Anaparatillus will make landfall. Unlike the Cyspidas and Panoplopodia of Ep7.2, the tetradecapods and Anaparatillus evolved on land around the same time. This may mean that they have the chance to evolve alongside each other and specialize for specific niches without the risk of competition. One group of tetradecapods may quickly fill the niche of insects and adaptable generalists on Mazi. We will call this group of tetradecapods the flexipods. Some flexipods may evolve to become smaller, having comparable diversity to the microspheres of Ep7.2. We will call this group of flexipods the Cathiforma. Some Cathiforms may evolve to have long, slender bodies and needle-like spikes on their tongues to eat leaf litter on the forest floor. Others may evolve bulkier bodies and stronger tongues to rip off the bark of the trees and eat the insides of them. As these herbivorous Cathiforms evolve, other groups may evolve to feed on them. Some may evolve to be flat and wide to mimic the Chytriveria on the ground, while others may evolve to feed on decaying matter, helping the Barunvera of Mazi and keeping the continent clean. While the Cathiforms evolve to be small and speedy, some other tetradecapods may evolve to be larger and more defensive, to defend against the large Anaparatillus that prey upon them. The bodies of these creatures may evolve to be more compact, with a few of their limbs losing their role in locomotion and specializing for other purposes. The first pair of legs may evolve into arms, to help their tongues grasp their food and bring it into the mouth. However, the last pair of legs may evolve into gonopods to latch onto partners during reproduction. Their tongues may also begin to specialize, evolving a split end with 2 blade-like protrusions that act like a pair of scissors to cut up the food their arms manage to grab and pull in. Their exoskeleton may also fuse in certain areas to allow them to grow larger and feed on larger food sources such as Cathiforms and medium-sized Parvutawa. We will call these less segmented tetradecapods the Tagmopodia. They grow up to 1 foot tall and live for up to 11 years. Unlike the tetradecapods, who only have an exoskeleton and an internal hydrostatic skeleton for support, the Anaparatillus have a fully fledged endoskeleton. This may mean that they could quickly capitalize on the as of yet vacant megafaunal niches of Mazi. One branch of the osteopods may evolve to have 3 joints in their leg, one connecting to the main body, one connecting to a knee, and one connecting to the foot. This will allow them to support larger body sizes, but it will limit their flexibility greatly. Let's call this group the sclerodontia. Another branch of the osteopods may evolve to have four joints in their leg, one connecting to the body, one connecting to a knee, one connecting to an ankle, and one connecting to the foot itself. This may mean these osteopods will not be as large as their sclerodont cousins. However, they will have great speed and maneuverability. Let's call this group the Ep7.2. Soon after these groups diverge, they may begin to specialize into their respective niches allowed by their limb configuration. The sclerodonts, with their three-jointed inflexible legs, may evolve into the niche of large herbivores and predators. Due to how dense the forests of Carpocormo are, large speedy creatures are at risk of getting stuck in odd places. This means that, while Apovlitos may play host to all manner of swift agile creatures, Mazi may play host to slower, bulkier creatures. Some sclerodonts may adapt for a herbivorous lifestyle, adapting to feed onto leaves and fruits of the Carpocormo. Their legs may be completely positioned under the body to give them as much height as possible to reach the treetops. However, even this won't allow them to reach the tallest leaves, so their neck and tentacles may elongate and strengthen to allow them to reach even the tallest branches, similar to earth giraffes or elephants. These creatures may also evolve a tail that curls downward to oppose their gonopods, to grip their egg sac and allow them to carry it with them, to not risk it getting damaged. We will call these massive sclerodonts the vaunopod. They grow up to 10 meters tall and live for up to 40 years. Another group of sclerodonts may go for the opposite approach. They may become bulky carnivores. These creatures may retain the semi-erect limb posture of their ancestors, as being tall may make them easily spotted by their main prey, the vaunopod. Additionally, their necks may shorten and may even be hidden by thick layers of muscle. However, this may mean that they won't be able to see prey from any appreciable distance, so perhaps their eyes angle forward to be able to see their prey from afar. However, seeing prey isn't useful if they don't have any way of killing them. However, they may evolve a strange way of attacking their prey. Instead of using their immense bite force to actively rip flesh off of their prey, their upper tentacles may evolve a complex system of muscles and tendons that pull the tentacles back like a bow, and with the quick relaxing of the muscles, their tentacles may dart forward and into their prey's hide, causing lethal damage. Meanwhile, their lower tentacles may evolve into arms to which they can use to secure their prey and have their upper tentacles propelled into their flesh, after which they will eat. We will call these lumbering titans the ctenopod. They grow up to 7 meters tall and may live for up to 45 years. Meanwhile, the Ep7.2, with their flexible legs, may evolve into small adaptable generalists that feed on small, fast prey such as the flexipods. Their legs may lengthen, while their bodies may become slender, allowing them to dart between small gaps between the roots of the Carpocormo. Additionally, these creatures may lose their gonopods, as, if they were carrying their egg sac in the gonopods, they may accidentally drop it and trample it. Their tentacles may also specialize, with the top pair becoming long and muscular, while the bottom pair becomes broad, flat, grinding surfaces to grind their shelled prey before passing them into their mouth. We will call these agile creatures the Oligodontia. They grow up to half a meter tall and live for up to 15 years. Due to how tall the Carpocormo are, the only arboreal animals on the continent may be the bogwingu and some species of Ep7.2. As a result, they may quickly monopolize the arboreal niches. One clade of arboreal Ep7.2, closely related to the oligodont, may evolve to hunt the bogwingu. These creatures may evolve to suspend their bodies from a branch using their flexible legs, allowing them to grow larger without the risk of falling from a branch, as their bodies are already hanging. This method of clambering through the trees is called suspensoriality, where an animal hangs from below a branch to be able to move along the canopy. This may allow these Ep7.2 to effectively hunt the bogwingu, as well as feed on the fruits of the Carpocormo that grow below the branches. We will call these hanging creatures the Arthronera. They grow up to 1.5 meters long and live for up to 25 years. From the strange macroproso to the towering vaunopod, the continents of Apovlitos and Mazi have seen some rapid changes to their inhabitants ever since they invaded the land. In the next episode, we will see the continents as a whole go through rapid changes, as we will see the formation of the first grasslands on the planet. Special thanks to the fan artists on Discord who submitted artwork for part 2 of this episode. You all have made it look so much better, and your contributions to the project are invaluable. Thank you all so much for watching. Don't forget to subscribe, like, and share your suggestions for future episodes. See you in the next episode.